All right, today we're going to start our new section of this unit, and we're going to look at systems of equations. A system of equation is just basically two different graphs or two different functions, and we look at where they cross. So what we're going to look at today is, first of all, what is a system? So we just need to have two different equations. So you can see here we got y equals x plus 1 and y equals x squared. They can be linear, quadratic, basically anything. And the solution is going to be the coordinates that work for both equations. So if you look at this one, we could probably do a little bit of estimating. If we plug a 2 in, we'd have 2 plus 2 is 4. And if we put 2 into the second equation, 2 squared is also 4. So that is a solution, but there's a good chance that we actually get a second solution. And in this case, I think it's, actually I'm not sure. We'll have to see if we can come back and figure that one out. So what you want to do to solve these, well, first of all, we're going to look by graphing. We'll do some algebraic methods later. So you want to make sure you have both equations as y equals. So once you graph them, you'll see in this case we got our two graphs, we got our quadratic, we got linear. We can see that they cross at 2, -3, and our second one crosses at -3, -8. So those would be our solutions, and you just write them as a coordinate just like that. So let's go back to that title page one and see if we can figure this out. So if we graph y equals x squared, that's just our quadratic that looks something like that. Graph y equals x plus 2. We'd have our quadratic looking something like that. So we got our coordinate, our first one, 2, 4, we already figured out. And our second one, if you figure out that intersection point on your calculator, it works out to -1, 1. So in this case, we actually do have two different solutions. Okay, so let's do a few more of these. So we want to graph y equals 2x minus 5. So same thing. On your calculator, just type in y equals 2x minus 5, hit graph, and then graph your second equation, y equals x minus 2. And in this case, once you graph them, we get one intersection points on your calculator. Once you have your graphs, you can see that there's one solution, and what you want to do is on your calculator go to second calc, choose intersect, which is number 5, and if you move your cursor near the intersection point, just hit enter a few times, and your calculator will give you that intersection point, which in this case turns out to be 3, 1. So that means when x is 3, y equals 1. So if we actually plug those in, if we were to go to our original equation and plug in the 3 for the x and 1 for y, we would see that both equations are indeed true for that coordinate. Okay, so here's a different one. So you can see we got y equals 3x plus 4. So graph that one. So that gives us a fairly steep line, something like that. And then you can see our second equation is a little bit trickier. So what we want to do is rearrange that equation. So let's bring the 6x over. So we'd have minus 2y equals 8 minus 6x. And let's divide by 2, -2. So we'd have -4 plus 3x. And you can actually see that we get a very similar graph. It ends up being just down below, something like that. So you can see in this case, just by looking at them, they look like they're parallel lines, which they are because their slopes are the same. So we actually have no solution in this case. We have no intersection points. Therefore, there's going to be no solutions. Where we look at the last one, we could see that it crossed at one spot, so we have one solution. Okay. Let's look at one more here, very similar. So in this case, so this was our title page 1, so we already did that, and we saw that for that one we had our quadratic and our linear looking something like that, and we had our two coordinates. They were at 2, 4, and -1, 1. So in this case we have two solutions. So you can see depending on the situation, you might have 0 solutions, you might have 1, you might have 2, and so on. Okay, here's another one. These ones look like quadratic, so if we want to graph them, once again you want to make them y equals. So for the top one, if we bring the y over and the 34 over the other way, so we'd have 2x squared minus 16x plus 34 equals y, and do the same thing for the second one. So you'd have 2x squared minus 8x plus 11. Okay, we have two quadratics. You can see both of them are 2x squared. So what happens with that one, just like linear ones, we actually get sort of, they're not really slopes, but we have the same a value in that quadratic equation. So because of that, we should get only one solution as well. So if you graph these two, so 2x squared minus 16x plus 34, 2x squared minus 8x plus 11, and we draw the graphs of those ones, we get our two quadratics, and you can see that they actually indeed only cross in one location. And in this case, that it works out to be a decimal. They're not a nice intersection point, but it does only work in one spot. So 2.875 and 4.531 if you do these on your calculator. So one solution again. So with graphing, you can easily see how many solutions there are, and then solve it and determine what those intersection points are. And we've been doing a little bit of this already throughout the year, but what comes in handy is when you have a complicated equation, you could actually solve this as a system of equations. So even though this one has no y equals, we can actually just graph each side separately. So graph y equals x squared minus 4x minus 2, and then graph the other equation, y equals x plus 4. And that will indeed give us our system that we could actually figure out what the solution is. So x squared minus 4x minus 2, let's do that one first. And then let's do x plus 4 as our second equation. And in this case, we get our quadratic, we get our linear, and we actually have two intersection points in this case. The first one's at 610, and our second one's at negative 1, 3. So we actually do have two intersection points, but the only thing we got to be careful of with an equation like this, we have no y values, so in this case we're only looking for our x solutions. So negative 1 and 6 would have been our two correct answers. And we could have done this like by rearranging it and simplifying the quadratic, but this just shows you a different way of using graphing to help you out. And we just finished doing absolute value equations, and we solved this by making it positive x minus 3 and negative x minus 3 and solved each equation. But we could actually solve this one by graphing as well. So if you just graph the absolute value x minus 3, so that'll be our V-shaped graph, something like that. Graph x plus 4, and we have our straight line, something like that. And when we graph these, we actually see, because once again we sort of have similar slopes, and I didn't draw my graph very well, let me fix that up a little bit. So we actually see that our second equation, the straight line one, actually ends up being parallel. So we end up getting a parallel line so that they only cross in that one location. And according to my calculator, it's crossing at negative 1/2 and 3.5. So once again, we don't have any y coordinates, so we just want the negative 1/2 version. So negative 0.5 would be our only solution that works in this case. And that's it. So you can see they're pretty straightforward questions. The only other type of question that you might get with this that comes in handy is a certain kind of word problem. So we've done lots of word problems throughout the year, and systems of equations and graphing in particularly will often help you with these. So let's try this one. It says a farmer has 12 meters of fencing for a rectangular pen that's inside of a corner of a wall. So if we were to draw this out, we just have our two sides. Let's call one y and the other one x, and that's it. So we know our perimeter, so x plus y has to equal 12, and it says in this question x times y, our area, equals 24. So now instead of substituting and things like that we did in the past, we can actually just graph both of these. So just make both equations y equals, so 12 minus x, and for the other one go 24 divided by x. Graph each of those equations, and even though the one is weird, the 24 divided by x gives us a rational graph, but that's okay, we would still get two different solutions. So in this case, if we draw our graphs out, so we got our rational graph, something like that. Our straight line graph is going to cross somewhere in there, so we can see we have our two solutions. Our first solution has an x of 2.5 approximately, and 9.5 for a y. And the other one is just the other way around, 9.5 and 2.5. So it really doesn't matter in this case which x and y we're dealing with, we just want to know our dimensions. So the right answer is 2.5 and 9.5 for both. So either our rectangle is drawn the way I got it sketched here, or it would be just tall and skinny the other way, but the same dimensions for both. And that's it. So solving a system by graphing works well. Just get your equations to be y equals, plug them in, graph them, and figure out where they intersect using your calculator and that second calc intersect button. And that's all for this topic. We're going to look at solving these things algebraically over the next couple of lessons.